Esse aplauso.
Hello guys, can you hear me, right? All right. So, yeah, today I'm gonna be talking, well, first of all, before you get to know me, get to know my research, and I get to know you as well, I'd like to express my deep gratitude to all of Ekoparty staff for allowing me to be here. It's a great honor to be here in the stage today with you. And I'm really happy that my research on mobile security caught your interest. And I really hope that everyone here in this room today could get at least one or two insights about mobile hacking or game hacking. So yeah, and basically my talk is called God Mode Mobile, Exploiting Mobile Apps with Game Cheats. And this is a story of how I managed to exploit a critical app, password manager app, using techniques commonly used for game hacking, for game cheats. So yeah, without further ado, let's go to it. So a little bit about me. My name is Bruno Sena, born and raised in Brazil, still living there. I'm working right now for Thallium Security, and I would also like to express my gratitude to them for they're always encouraging me to share my research. I have an expertise for offensive security, but more focused on mobile security, a degree in computer science, and I have a hobby, which is game hacking. And this hobby is basically what, game hacking was what introduced me in the first place into cybersecurity. And game hacking, it's the source of all this research. I'm also the creator of MobSec Crew, which is a community for sharing mobile security contents in Brazil. I organize mobile security events in events in Brazil, like BSides São Paulo and H28C. So a little bit about the agenda. Although I started in cybersecurity throughout game hacking, I never actually taken some time to explore mobile game hacking. So a few months ago, I decided to try to explore a little bit more, a little bit further. And I started digging and searching for techniques for game hacking in Android Android devices. And as I was searching and digging and discovering new technologies and techniques for game hacking on Android, at some point I started to wonder if these techniques that I was learning and using to explore game applications could be used to explore more critical apps, like maybe banking apps, mobile banking apps, or a password manager. So the first thing that, as I started to search for games to explore, to hack, I first got this game, which is Cube. And this game is basically developed originally for PC. It was developed with this engine, which is Cube engine, which uses C++. And then this game gained a port for Android. There are a lot of tutorials on the internet about how to exploit this game for the PC version. But I decided to do it on Android. How could I manage to do it on Android? And this engine, this Cube engine, it is a very simple engine for game developing. And this was very important because it helped me a lot on exploring this game. So the first thing that I did was I got the APK for the Android version of this game. And I was searching for the load library function on the Java code, because as this game was originally developed for PC, for Windows, all the game logic, it's not in the Java code. The game logic, it's entirely contained on native library. So we can see here that we have two functions, load library, and they reach out for main and server. So these libraries, they contain the game logic. So we're gonna search for them. So as any other application, mobile Android application that loads native library, they are normally commonly stored on /lib, ARM64, and these is the the libmain.so, which contains all the game logic. So now that we have a libmain.so, a .so file in hands, we can go through some game hacking techniques, and one of them is Ghidra. So as I said, the game engine that was used to develop the Saltcube, it's a very simple game engine. So as it is a very simple game engine, it keeps all the name functions in the code, the debug symbols. So it's very easy to detect the name functions. So I started to do some research, and I decided to go through some damage functions. So we can see here a lot of do damage functions. So I found this one in this location, do damage. So let's see what it does. So as we can see here, we have the function do damage, and it receives some arguments. The first one is an integer called damage. So it's probably the amount of damage that has been dealt. We have two entities called player entity. We have a P1 and an actor. So we can presume that the P1, the actor is the player who is inflicting damage, and probably the P1 is the player who's being damaged. We have also some other arguments like an integer for gun, which is probably the ID of the gun that is being used. And down here, we can also see a dereference for player 1. So as we go through it and look a little further, we can see that this dereference, it is our player, the instance of our player in the game. So our player 1 are our character in the game. So this will be very important. So to develop a simple exploit for God mode, for those of you who are not much into games, God mode is normally a cheat used to turn your character invincible. It does not die, it does not receive damage. So that's what we're going to do. So we already have all we need. We have a function that causes damage, and we have the instance of our character. And we know how it all fits together. So as we are in an Android environment, we're going to use a Frida. But it's a tool used to hook Frida mobile Android apps in runtime. It can also be used for Windows and iOS applications, but we're going to use it here for Android. This is a Java Python code, which is just loading the Frida into our app. So our app is that package, net.cubers.asaltcube. And we're going to inject the Frida script into the process of our app, which is asaltcube_godmode.js. So this is actually the Frida script. So here we're going to find the base address of our libmain.so, which is loaded in the process, attached to the process of our app. And I'm logging here when I found the libmain.so. And then here I'm just logging. Every time that the do damage function is called, I'm just printing that arguments that we saw earlier. So the player entity, the gun, the integer for damage, and everything else. And down here, we are finding the effective address of our character. So that is the static address. We're going to find the actual address of our character in the game in the memory. And this is where the magic happens, and it's actually pretty simple. What I'm doing here is that I'm checking and verifying if every time that the do damage function is called, if the player who's being dealt damage, who's being damaged, is myself, is my character, I'm going to just pat the damage to 0. So this way, we should be invincible because every time the damage is caused to me, the damage will be patched to 0. But every time the do damage function is being applied to another player, it will remain original. So let's see if it works, if this works. So I'm going to start my loader .py, which loads the Frida script. So it found the lib. So our Frida script is already running. So I started a common match. Don't mind me playing. It's very difficult to play it on Android. And I'm also a shitty player. So you can see that I can hit the other player, and every time I got shot, we can see that the damage is being patched to 0, so my life doesn't change. So we can see a lot of damage patched to 0. but I can still kill the other characters because I'm not changing the value applied to them. So I can still cause damage to them. All right, nothing particularly remarkable, interesting, but all right, it's a very simple sheet, nothing particularly remarkable about that. But what can I do with this? And then I started to wonder if there are any other Android apps that use this mechanism about probably an application that was originally developed for Windows, for PC, and then gain a port for Android. Could I use this technique to exploit it? Well, I went searching, and then I found this application, which is KeyPass to Android. Well, KeyPass is very famous password manager on Windows. It was developed with C#, and it's a password manager. And KeyPass to Android is a port for Android that uses the libraries from the original KeyPass. And although KeyPass to Android is not an official port from the KeyPass, we can see here on Play Store that although it's not official port, it has more than 1 million downloads. So a lot of people use this application. So that's very interesting. So what I did was the same thing that I did with the AOC.Cube application. I opened it on JDX to analyze the Java code and went searching for loader library functions. And as I was searching through the load library function calls, I found these libraries, and they caught my attention because I was reading and I saw MonoGen, MonoNative, MonoDroid, and I began to wonder, well, I've actually seen it someplace before. And then I went back to memory and I remembered where I've seen it. And that's Unity. Unity is one of the most famous game engine used for a lot of different types of games, both 2D and 3D games. It is a cross-platform development game engine, and it scripts with C#. It runs C#. And Unity has two kinds of code execution, of compilation. One of them is Mono Runtime, and the other is IO2CPP. The main difference on both of them is that Mono Runtime uses JIT compilation, which is just-in-time compilation. So it executes the code on runtime. It compiles the code on runtime. It has a moderate performance, so it works pretty similar to Android on JVM. So it creates a bytecode called Common Intermediate Language, and this bytecode is executed on a VM, which is Mono Runtime VM. And IO2CPP uses AOT compilation, so it compiles the code before. It has a higher performance, and it converts these bytecode into C++. So it strips the original code. So it's harder to reverse engineer IO2CPP because we don't have the original bytecode here. We just have the compiled version from C++. So it's harder to reverse engineer it. It's possible, but it's very much easier to reverse engineer Mono Runtime games. So we saw that probably that application, the KeyPass was running on Mono Runtime. So I decided to study a little bit more about Mono Runtime and try to understand how it works. So to do it, nothing better than try to exploit a game developed to run on Mono Runtime. So this is Cuphead. I believe that most of you know this game. It was released back in 2017, and it was developed using Unity engine, and most importantly, it runs on Mono Runtime. So here is a common gameplay, nothing changed. The boss can hit me, I can hit the boss, common damage, everything, all right. So I went searching for the game data. So here, the folder with the game data. As digging through the game files, we can see here that we have two folders, Manage and Mono. So we see here that this game actually really runs on Mono, but we're not going to use the Mono folder right now. We're going to go through the Manage folder, which contains the DLLs, which contain the game logic. So we can see here a lot of DLLs. Also, we can also see some mono-related DLLs. But most importantly, we're going to see this assembly C# DLL, which is the main library of our game. So with assembly C# DLL, we can now go through another technique very commonly used for game hacking and Windows hacking too, and exploiting Windows libraries, which is the NSpy. The NSpy is a tool used to decompile DLLs, and we're going to use to analyze the assembly C# code and try to understand the game logic. So here we have our decompile assembly C# library, and I'm going to do the same thing that I did with ASUG. I'm going to search for do damage functions. So as I was searching, I found this property called basic project file damage, and it's contained here in this class, weapon properties, level on weapon p-shot, basic damage. So let's see what it is. So in the weapon properties, we can see here the class basic, and we have this damage, which is set to 4. So it is related to that p-shot. So p-shot is basically that little burst of fire that we shoot from our character. It's the basic attack from the game. So I was thinking, what would happen if I just change this value to something ridiculously high? And that's what I did. So I changed it, and let's see if this works. So now I changed it and recompiled it, and let's see if I can. Let's see what happens. So the boss can hit me. He does anything different. This shot is not the P shot because it's a special shot. But when I hit him with the P shot, I kill him right away with just one shot. And I can do this with any character because my damage is ridiculously high. So again, the second phase, it goes right away. So yeah, basically here we are killing everyone with just one hit. It's all right, interesting, cool. But back to our key pass Android. What can I use? Why can I use this? So back to the libraries, we have again MonoGen and some other libraries here, but we don't actually see anything related to the key pass to Android. We just see MonoGen, some Xamarin related libraries, and I'm going to talk very soon about Xamarin. But we don't actually see nothing related to the logic about password storaging or password managing. Nothing related to that. So where are them? Where are they? Where are the actual libraries that we want to tamper with? So I went searching, digging a little deeper into the APK, and I found this folder called Mono, and these classes called Mono Package Manager and some others. So I decided to look for it. So inside Mono Package Manager, we can find these two functions, which are get assemblies and get dependencies, and both of them reach out to resources, the resources folder. So I went to resources folder. Inside, there was another folder called assemblies, and I found these two files, assemblies.blob and assemblies.manifest. When I accessed assemblies.blob, I didn't find anything interesting, just a file, just a message saying it's a file too large for view, so nothing interesting here. But when I accessed assemblies.manifest, I found something really interesting. These names, they are, I discovered that they are names pretty much related to libraries. So you can see here KeyPass lib2Android, KeyPass autofill parser, business logic, a lot of things related to KeyPass. So all right, we kind of found the libraries that we want to tamper with. But these are just names, just information. They're not the actual libraries. So how can I get them? So all right. We know that we are in the right path, but we didn't get yet the actual libraries that we wanna analyze. But another thing that I found interesting was these Xamarin libraries. So we have basically the KeyPass Android libraries, and all the other ones are related to Xamarin. So I went searching to know more about Xamarin, what is it? What is it? And Xamarin is basically a mobile app development framework, pretty much like Flutter, on which you can develop the application on .NET using C#, and it creates cross-platform apps. So you have only one code, and it's using .NET and C#, and it creates ports for both Android, iOS, Windows, and everything else. It's a Microsoft ecosystem tool. And one thing that, as I was searching and looking at the documentation, Xamarin actually runs on apps on Mono Runtime. So it all kinds of fits together because we know that this application was probably developed using Xamarin, and that's because that's why it runs on Mono Runtime. So I decided to look a little bit further into research about Xamarin application, and I found this article from GoSecure, and this article actually helped me a lot throughout this research. And this article talks about certificate pinning on Xamarin developed applications on Android. And very briefly, what this code does is that that bypasses certificate pinning applied on Android applications developed using the Xamarin framework. And the most important thing that I found about this article and this code to bypass certificate pinning is that there is a freedom module used specifically for managing Mono Runtime. So that actually helped me a lot. So what this code does is that it finds the native library that wants to tamper with. So in this case, they're gonna have to hook into the system.net HTTP library. Once it's hooked to its library, we want to find the class that we want to tamper with. So in this case, it's the HTTP client handler. And the method that we want to hook is the create default handler and the HTTP message invoker. And here we are instancing these methods and changing the client handler. So very briefly, what this code is doing is it's changing the HTTP client handler so that it creates another handler that doesn't validate the certificate pinning. So once this code is running, once this freedom code is running, it will change the client handler, the HTTP client handler, and should not verify the certificate because it's been modified. So when we run and use this application developed for testing the script, we can see that when we run it without the script, we got an SSL exception. But when we run the free script, we got an OK message. So it has bypassed the certificate pinning, the certificate validation. All right. So we're now that we can manipulate Mono Runtime using that freedom module, but again, we do not have the libraries that we want to analyze and tamper with. So back to these files, these assemblies.blob and these assemblies.manifest, how can I actually get the libraries that I want to analyze? And that's actually very simple. That article from GoSecure that explores the bypass of certificate pinning on Xamarin apps, they share this tool, which is PyXamStore. And basically what those two files do is that they kind of parse all the libraries contained on an Android application into one single file, which is that assemblies.blob. And the assemblies.manifest is the map for parsing and to also to undo the parsing. So what this tool does is that it's undo the parsing. So we can run it on the folder containing both assemblies.blob and assemblies.manifest, and we can see here that it's extracting all the libraries, all the DLLs that we have on that assemblies.blob. So here we have them, all the DLLs, both Xamarin DLLs, but most importantly, we can see there the key paths to Android DLLs, and now we can go searching and digging and analyzing them to try to understand the logic behind the password manager application. So what I did, just like I did with Cuphead, I opened it on DNSpy, all the KeyPass to Android related, all the KeyPass to Android related DLLs. But before starting searching, and by that time I didn't know what I was actually looking for. So I decided to go a few steps back into the Java code and try to understand a little bit more about the application. I will very shortly show you the actual application, the actual KeyPass to Android app. But when as I was looking back into the Java code at JDX, I was searching into the Android manifest, and I was looking for all the activities contained in the app, the activities, all the interfaces in the application, and I found these two activities: password activity, which is the activity on which the user submits his master password, and then the application validates it. And then if it's the correct password, it unlocks the database contained all the passwords that are being stored there. And there's also this activity called Quick Unlock. And Quick Unlock is a feature present on these applications on the KeyPass to Android. And it's a feature that allows a user to unlock the database without actually submitting the entire password, only by submitting the three last characters of his password. So I decided to search for this Quick Unlock activity, all the Quick Unlock related functions on the code. So I was looking a little bit further back into the Java code to see where the Quick Unlock method was being called, the Quick Unlock class, and I found that the library that we have extracted that contains the Quick Unlock logic is this one called KeyPass to Android Setup 2. So that's the library that we want to analyze on the NSPy. So back in the NSPy, I've opened the KeyPass the KeyPass to Android lib that we want to analyze, and I went searching for Quick Unlock related stuff. So inside the Quick Unlock class, we can find this method called onUnlock, and it's very simple. Its functionality is very simple. Basically, what it does, it receives a string that is being passed in this edit text, which is probably the edit text on which the user submits the three last characters of his password, and then it compares to a string that it calls expected password part. So it's pretty simple. We have here an if that it checks if the password from edit text is equal to expected password part. And if it is, it calls this method called unlock, unsync, and close. So this method is actually the method that unlocks the database that contains all the passwords contained in the application. So we already have all we need here. We just know how the unlock of the database works. So we're gonna go with Frida and try to develop a Frida script, just like we did with ASaltCube. And I'm gonna use that Frida module called to hook into the Mono Runtime. So here, right here, I'm just enumerating all the DLLs on the application. So in the package of KeyPass to Android. And when I found the target DLL, which is the KeyPass to Android lib, which contains the Quick Unlock class, I'm just printing here to know that I found the correct DLL. So once I've hooked into the right DLL, what I'm going to do here is try to identify the Quick Unlock class and hook into it. So here, I'm just, when I found the Quick Unlock class, I'm just also logging here to know if it's working. So we already have hooked into the library, which is KeyPass to Android lib, and here we are hooking to the class. So we already have the library, the class. Right now, we're gonna need to hook into the methods that we wanna tamper with. So both of them are onUnlock and unlock and sync and close. So we're gonna have to instance, then create a new instances of them. And here is basically where the magic happens and the exploit is done. My goal here is to I could have actually do this in many ways. We could exploit this in many different ways, but I decided to go simple. We know that onAnlock receives a string which comes from the edit text, which should be the 3 last characters of the user password, master password, and it checks if it's the correct 3 last characters. It compares to that expected password part string, and if it's correct, it calls the unlock and sync and close method. So what I decided to do, once we have 2 instances of those methods, because we have hooked into the class, what I can do here is just every time that the onAnlock method is called, we can call the unlock and sync and close right away, and then the application shouldn't compare any password at all. So here I'm just printing every time that unlock and sync and close is being called to know if it's working. So anytime that the onAnlock is called, onAnlock and sync and close should be called right away, and the application shouldn't compare any password at all. Here I'm just here is just the targets assembly, which is the assembly that contains the logic for onAnlock. Well, so let's go for it and see if this works. So here, this is the application, the KeyPass Android. I will go with a random password, and it doesn't open because it's the wrong password. So right now I'm gonna submit the correct password, so we can see here a lot of passwords stored in the application. All right, working perfectly fine. And now I'm gonna run it with the actual bypass, the exploit, which is the bypass underline quick unlock JS. So we can see here that it found everything that we need: the DLL, the class, and the methods. And when I submit any password at all, it unlocks the database without being the correct password. So as the application actually doesn't validate any password at all, we actually doesn't need to submit any password. So I'm gonna run the application again with the script, so it finds everything that we need. And I can just click there, quick unlock, and it unlocks the database without any password at all. So that's how I managed to exploit the KeyPass to Android application. And I think this is it, guys. Hope you enjoyed it. If you have any questions at all, please feel free to share.
Hello. Thank you for the lecture, for sharing your research. I'm also from Brazil. I'm glad to meet you. I hope we can get in touch later. I actually have a lot of questions, but I'll focus on the process here. I didn't understand very well, why did you switch to a Windows application, Cuphead, and then switch back to the mobile? What was the gain of this process?
I decided to show you the Cuphead game because when as I was searching throughout the Android application, as I discovered that the application was running on Mono, I recognized Mono, but I didn't remember where I've seen it. So I went searching, and I remembered that Mono is the VM that runs the Unity games, and both Cuphead, developed on Unity, runs on Mono Runtime, as well as this application. So I wanted to show you that for what Mono is used, which is very commonly used for Unity games, but that application even if it's not a game, in the case of the password manager, it also runs on the Mono Runtime. So I wanted to show that the Mono Runtime, it can be used for different types of software.
Hi, thank you for the talk. I see that most of the techniques used in the talk were analyzing the code. Do you think this vulnerability could be solved by obfuscating the code? And if the answer is yes, what do you think about why the developers doesn't obfuscate the code to prevent this?
Yeah, so as I mentioned earlier about Unity, just give an example about Unity. Unity has also that IO2 CPP, which is another kind of code execution, which is it strips the code. It's a AOT compilation, so it converts the bytecode into a native code. So in this process, the Unity actually implements some kind of obfuscation. So the Mono Runtime, it does not do that. So it runs the bytecode, and the bytecode is very commonly still stored on the application files, on the game files. So yeah, IO2CPP is more secure in this way, and I believe the developers use this technique because actually the Xamarin framework, which is used to develop multi-platform application, for doing that they actually use Mono Runtime to, you have one single code which is .NET, C#, whatever, and to run that application on multiple platforms, it uses Mono Runtime, which is a VM that can be placed anywhere, like an Android or an iOS or a Windows. So it's easier to run one single code into multiple platforms. It turns the code a little bit more insecure, but in the perspective of a developer that wants the application to run on different environments, it's an advantage.
Well, thank you so much for the talk. It's really interesting. I was wondering, in the examples you showed, you did like static analysis on the code, be it native or Xamarin or whatever, and then you used Frida to hook the function. When at that point, you already knew exactly what you wanted to happen. Now, if the code was obfuscated or if it was more complex or something, you will need to perform some kind of dynamic analysis first.
Yeah.
Have you found some way to debug either native code or C# code other than using Frida? Sorry.
Yeah, we can. In this case, we could have used not only Frida, but other tools commonly used on Android to debug the application, like Objection, which is a tool that uses Frida, and it's very useful for debugging. So yeah, once we have the code decompiled, we have the DLLs, and I knew exactly what I was looking for. It was easier. But in the case of an obfuscated code, I think in the context of Android, Frida and Objection are the most useful tools for debugging. So I believe I would use it. Probably a lot of using of Frida trace, which is a very cool tool for debugging, and in this way we could have tried to understand without the actual code how those functions were working, like the quick unlock and everything else.
Okay, thank you.
Anyone else? No? Okay. Big applause for Bruno.
Gracias.
In a few minutes, we are going to continue the talk.